Welcome everybody to the iSystem webinar Continuous Integration, Jenkins and iSystem tools. Some information up front before Alesh starts. Alesh, can you give me the next slide, please? Yes, thanks. Okay, this is also important. So my name is Errol. I'm the moderator, and Alesh is the speaker. He will lead you through the presentation in a minute. Next slide, Alesh. During the webinar, you are all muted. I can unmute if needed somebody, but mainly the chat functionality gets you in contact with me or questions. There's a question writer in the menu where you can write down questions, and we try to answer them right away or during the webinar or at the end. And there's also a possibility at the end of the seminar to so we get all the answers in a file, and we will answer the questions individually after the webinar. Okay, next slide. The webinar, continuous integration, is a very big and huge topic. So we will give you mainly an overview of what's possible, especially in combination with iSystem tools and how our interface is used to integrate this tool set from iSystem in a continuous integration process. And Alesh will give you at least an idea how to prepare such an environment, how the testing is done with our tools, and the API is used. And this is the outcome of the webinar in about 35 minutes. Okay, Alesh, next slide. I guess that's you, right?
Yes.
Okay.
Hello. Yeah. Welcome to our webinar. What is today's agenda? Firstly, I will make short introduction of continuous integration. Next, I will briefly present the iSystem tools and software applications. Then I will describe a procedure how to generate JUnit compliant Python test script used for continuous integration. Next, I will briefly present the Jenkins installation procedure for Windows 10. And at the end, I will describe how to create Jenkins job and how to configure test reporting. So let's start. So what is continuous integration? It is a software tool that basically checks if it is possible to build a software project. There are several continuous integration software available, some running locally and some running on the clouds. Most of them are open source. A developer submits his code to repository, either local or hosted on the cloud, when he finished making changes. A continuous integration server, for instance, Jenkins, BuildBot, or Bamboo, checks out a copy from the repository and then attempts to build the project. If it is able to build successfully, we get a pass, otherwise we get a fail. However, if we want, the continuous integration tool can do much more. We can add a unit or a system integration testing after the build process passed successfully by adding a development tool such as BlueBox on chip analyzer and a target microcontroller board. Our continuous integration can execute a test on our target ECU. Doing so, we can check if the compiled code could be executed on the target CPU. Firstly, we can prepare so-called smoke test. This software test comprises of non-exhaustive set of tests that aim at ensuring that the most important functions work. The result of smoke testing is used to decide if a build is stable enough to proceed with the further testing. Jenkins is one of the most popular automation server for continuous integration. It is a free open source software program based on Java. It can run on most popular operating systems such as Windows, Unix-like operating system, including Linux and Mac OS. We can easily install and configure it via its web interface, which includes building help and error checking. Plugins make Jenkins really powerful and adaptive automation tool for development and testing. With plugins that are in hundreds in number, we can really enhance the integration into existing environment and the power of the Jenkins as a test automation tool. We can extend the functionality of the Jenkins without creating our own version of Jenkins, but with the extension of a functionality. Our added functionality will be always there as an extension to the new core versions of the Jenkins. With the Jenkins, it is really easy to distribute work across multiple machines, helping faster builds, tests, and deployment across multiple platforms. With the use of continuous integration, we can find bugs and stabilize new software sooner. All this can increase cost saving and application quality. An automated testing with continuous integration improves a transparency of the software development and also a developer morale. Besides these benefits, an automated testing with continuous integration has a challenge. We need to prepare new tests for testing a new software functionality. E-System tools are built around the IC5700 debugger. The specialty is the expandability of debugger with several add-on modules. On the picture, first is CAN-LIN add-on module used for network analyzing. We can analyze CAN-LIN buses and inject messages to the buses. ADIO add-on module is used for analyzing analog and digital I/Os and driving the target with signals. ActiveProbe is special debug and trace connector for high bandwidth tracing and profiling of controllers such as Infineon Aurix and ARM Cortex. If more than one add-on module should be connected, the hub expands the ports from 1 to 4 pieces. At the back of the hub is special Ethernet port used for the enabling synchronous debugging and trace with 2 iSystem debuggers on 2 CPUs on 2 different ECU targets. On the left is a screenshot of the winIDEA IDE. It has some advanced features for speed up debugging. The real power of winIDEA can be found in its analyzer, a program and data trace visualization tool of trace, code coverage, and profiling measurement. It also supports real-time operating system awareness. iSystem can offer some advanced tools for timing analysis to cover arbitrary timing scenarios like AutoSAR event chains. Trace Analyzer can trace and profile signals on I/Os, the CAN-LIN messages with the use of add-on modules. Our testing approach reuses the BlueBox debugger together with a target ECU. winIDEA project contains the configuration for the debugger and target CPU. The automation of the debugger together with IOM modules, some APIs are used. iSystem Connect, iSystem Test, and iSystem FNet. We can create tests with a testIDEA application, or we can write scripts on our own. We can also use an internal testIDEA script generator, and we can generate out of testIDEA a completely JU-compliant Python script that can be used for the continuous integration without any additional work. We can download from iSystem webpage the 3 iSystem APIs for automation and testing. iSystem Connect API is used for automation of the debugger. iSystem Test API is used for testing. We can create unit, system test, and test reporting without any instrumentation. eSystem FNet API is used to automate CAN, LIN, and ADIO add-on modules. With this, we can generate stimulus for the ECU during the continuous integration testing. eSystem testIDEA is an application for embedded software test. We can prepare unit and system test, and we can use stubbing of embedded function by using testIDEA GUI. We can inject faults. With the testIDEA application, it's possible to create several test suites. We can measure coverage and timing of execution with the iSystem trace feature. testIDEA can create several reports with results of testing and other measurement. testIDEA reporting can comply the JUnit format. The JUnit XML, the JUnit testing framework introduced an XML file format to report the test suite execution. The JUnit XML report can be processed by the Jenkins. In the case of writing a standalone Python test script by using iSystem APIs, we need to take care that the test report complies JUnit XML format. We can use also 2 Python modules, UniTest, also known as PyUnit, or JUnit XML. On this slide, we can see some snippet of the JUnit XML format with the XML text with descriptions. Here we can see a snippet of the test report in JUnit XML format. There were 9 tests executed, of which 4 tests have terminated with the exception error, 1 test has failed, the test result evaluation failed, and of course 4 tests have passed. After knowing some details about testIDEA features and continuous integration with Jenkins, we can proceed with the generation of the Python test script by using testIDEA. First, we need to prepare several unit and system tests with the testIDEA. Later, we can generate Python test script. When generating the Python script, we need to define the path to the iSystem Connect DLL, and we need to check that the test report will be in JUnit format. testIDEA script generation supports importing of external Python modules, so we can include Python code for driving other external devices if they have Python module for automation. After generating the test Python script, we need to prepare the Jenkins server. Here we have a couple slides on how to install Jenkins server on the Windows 10. We can find on the jenkins.io webpage the documentation how to install Jenkins on numerous operating systems, including the documentation and the installer for the Windows. After downloading and running the Windows installer, we just need to follow the installation instructions. After the installation is finished, we need to open in a browser localhost on the port 8080. After Jenkins page is displayed, we need to unlock Jenkins with initial password and select a configuration with suggested plugins. Next, we need to complete the creation of an admin user. Then, we can start using Jenkins. Before starting with the creation of the Jenkins task, we can have a short overview what we can prepare with the Jenkins. We can create a pipeline or freestyle project. Jenkins task can run on a master or on a client node. We can run Jenkins task on the client PC while the Jenkins server runs on the server host. We will prepare Jenkins continuous integration job, and we will add a step with execution Python test script. Jenkins will execute the Python script and run a test with the use of iSystem Debugger on the target ECU. Creating a new freestyle project requires clicking on the new item from the Jenkins menu. Then we need to enter the name and click on a freestyle project. We will skip the application building step with this presentation. After that, we need to add the execution of the Python test script in the freestyle project build configuration. We need to create an execute window batch command for running the Python test script. At the end of running the test script, the JU unit XML test report is generated. This report needs to be published in the post-build actions. The name of the test report was defined and stored in testIDEA configuration. We need to add .junit.xml extension to the report file name for publish JUnit test result report setting. The testIDEA can also generate HTML test reports and coverage measurement HTML reports. These reports can be included into publish HTML reports or the freestyle project configuration. After saving the configuration on the freestyle project, we can manually start the Jenkins test by clicking on the Build Now. Of course, Jenkins can be configured to run tests at a given time. After running tests, we can check the test results. After a couple of test runs, the Jenkins also displays the test result trends. Next, we can also check the testIDEA HTML test report that was included into the Jenkins reporting. With the browser, we can also browse the coverage measurement that was measured by the iSystem Trace Analyzer. We can check with the browser what lines and branches have been executed or not. The coverage measurement statistic is also part of the coverage report. When creating Jenkins pipeline job, the configuration is a bit different. We need to prepare batch file for the Python test script execution. This is then included into pipeline stage of the pipeline Groovy script. The test and coverage reporting are added at the next stages of the pipeline Groovy script. At the end, I would like to mention that we can find on iSystem webpage www.isystem.com additional help documentation and trainings on how to prepare testIDEA testing and on debugging with the winIDEA. Now I will finish my presentation. I will give back the word to the moderator.
Okay, thank you, Aleš. Yes, I'm here. Thanks. This time it was a little bit a shorter one. We have one question coming in right now. Let me see if I can just read it. Setup winIDEA running JTAG connected has to be connected to the Jenkins master at all time while job is running. Did you get this, Aleš?
So, just checking. Message continuous handout. No, what? I'm clicking, but I cannot. I don't see any message. Sorry.
No, I'm reading the message for you. You just have to answer. So one question is, for example, for testIDEA, do we generate automatically unit tests as other unit test tools do?
Oh,
So the question is more or less, how do I get my tests? Is this automatically also possible?
well, just we can generate some part of the unit test, but not really everything, because the testIDEA is prepared like this. That most of the test vectors should be manually typed into the unexpected result. We don't have any analysis what should be the expected value. But if you have this test vector and results, you can we are able to import those test vectors and tests into the testIDEA. That's possible. And we have also a generator tool that also prepare the test vectors, but the expected values should be calculated on your own and entered into the test.
Yeah, and
this
automated automated test case generation. If there's a test case specification, it may be good to generate automatically test cases, but if by parsing the code, it would be maybe not the ideal way to do it. Yeah, but we don't have this possibility, for example, to generate it automatically out of a code or so.
Yeah, there is no simulator. We run the test on the real target, with the real signals. This is the differentiator with our test tool.
Okay, and the first question that we got was, so if we connect the BlueBox via JTAG to the target and to the Jenkins environment, has this be connected all the time? So winIDEA running, JTAG connected, and so forth. I mean, while the test is executed, yeah, sure.
Yeah, I can respond. We do the test. We have a test setup here in our office. We usually connect also the power switches, which are Ethernet controlled. And when we start a Python test on the specific ECU, we just power up with the Python command the right power switch, and then we execute the test, and then we are switched off. Yeah.
Okay. Good answer. Next question. Can we run our own manually written Python scripts that uses the iSystem SDK? Sure.
Yeah, sure. I had a webinar, last webinar, I gave overview how to use iSystem.connect or iSystem.test, and you can write your own script. That's why I put also this JUnit XML description, because I have to let you know that the results of the report should comply that format, and then it's easy. So you can write your own Python script, and we do in our office write our own test scripts also this way. Yeah.
Another question was all tests configured by testIDEA or within testIDEA, can they be translated in Python scripts using the iConnect SDK? I mean, by...
Yes, I will respond. Yes, of course. Whenever you prepare any test inside the testIDEA, we have internally in testIDEA a Python script generator. And this basically generator use iSystem.connect and iSystem.test. I had slides how to go into the, when we into this window for generation of this script, but on the test on our web page there is really excellent training how to use testIDEA, and there I think it's a lot of slides how to go and use this script generator. So the best way is go there and check the training. That will be really I would say, the best advice for you.
Okay, another question. Do we have to install the Python SDK on the Jenkins server to be able to run the tests too?
If you split with the server on different PC and the client, you need just on the client side the Python and the SDK, because the Python client will then actually execute this Python script. Yeah, on the server side, you don't need the Python installation. But if you use the freestyle that runs on the server, then yes, on the server should be also installed. It depends where this Python script is called.
Okay. Also, another interesting question about code coverage measurement. Is it limited in time or in C units that are measured? Use case would be reuse hill test for hours while measure coverage in the background.
Yeah, so this is heavily dependent of the CPU and the trace connection. It depends of the actually CPU capabilities and this trace throughput. It's possible to configure at least that during the test like this, that we have, let's say, several sequence of this testing, and we can trace. Okay, if we have one giant test that the hours, you just need to define that you have, let's say, a lot of memory space inside the hard drive, because the trace will be automatically added and written to the hard drive of the PC. And you can always usually configure the trace that you trace what is of interest. Only some, let's say, some CPUs are capable of tracing for hours everything. From my experience, some Cortex, they have quite good trace engine inside. Or if you use, for instance, Strike or our AGP Aurora trace, this is also possible. But I would say, ask our support. We will help you how to configure trace. Usually, let's say 98% trace scenarios it's possible to trace, but with so-called qualification. We just trace portion what are of interest. And when we don't, we trace the non-qualified code, the trace engine is and the buffers are able to recover from the throughput, and So one solution is that you trace maybe 3 times the same test, and each time you trace a different proportion of the code, and then we have tools how to merge all the trace files together, and then you'll get a real picture of what's happening all time. In the case that you have a system that's not able to trace everything all the time for 3 hours.
Yes. So this is a good topic for our next webinar, I guess, coverage and endless recording, which is really tricky in certain
But I must say
cases.
to you, you don't need any instrumentation for that. If you are using our trace analyzer tool, you just enable it, configure it, and we can help you how to the best way, what is the best configuration for you. You can ask our support, and then without any instrumentation, without any drivers, you just perform testing and coverage measurement.
Okay, a last question. How can the results be compliant to the JUnit format if we would write the tests manually?
Yeah, it's not that difficult, because I have 2 slides. One was a bit of a snippet of the JUnit XML format, and then the next slide was actually the test report generated with the testIDEA. And it's not so difficult. Then you have test suites, and inside test suite it's one test suite, and then you have what is the number of all tests, how many exceptions, errors do you have, and how many tests failed, and that's it. And the next line is just you name of the test, and then if everything is so, you just don't add anything to this XML tag. If fails, you just say failed and the reason, and then the next would be for the exception, error, exception type, and etc. It's not that difficult to prepare on your own, the JUnit XML. It's not really complicated XML in reality, or you can reuse two modules I suggested during the webinar. One is PyUnit and other one is JUnit XML. Those modules are available for Python and you can reuse it. It's not that difficult.
Okay. Okay, thanks, Aleš, for all the answers. I guess if you are interested in getting more in-depth answers from Aleš, he is available. We are the email address that you see here on the bottom, webinar@isystem.com. We will forward the questions to him. There was also one question about recordings of these webinars. Yes, we do record them and publish them on our webinar, on our YouTube channel. You can access this channel via our homepage, isystem.com. Also, the Python scripting webinar is there. We also have a knowledge base available on isystem.com. You can access this via support.isystem.com. And if you want more information about webinars, future webinars, you can register to our newsletter or just go to our event page, which is also mentioned here in the link, meetus.html. Last slide, Aleš.
Yep.
Could you click? Yeah, these are the next webinars. So we have April 22nd, how-tos classic timing analysis webinar. It's done by Felix, an FAE in the US. It's mainly about profiling and how, and also background about tracing. That would be made also answer the question about coverage, for example. You get some more insights there. And the second one about our digital I/O module and SPI add-ons with iSystem tools done by Aleš, April 30. So another 2 ones to go for this month. So registration is open, so feel free to register now.
Yeah, so thank you for joining us and stay safe. That's from my side.
Yeah, stay healthy, and look forward to join you again in one of our webinars in the future. Thank you. Goodbye.
Yeah, bye-bye.